Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let me continue with the second part of our content, which is in the previous video we covered on requirement engineering, right? Let's now move on to system design. Okay, for this system design, the main content covered in this video is system modeling and architecture design. Right, what we have seen so far just now when we are talking about class diagram is about structural to represent structural modeling of the system. Okay, let's look at the other type, which is called behavioral models. Behavioral models, if you um, remember, when you are looking at the class diagram just now, we are basically knowing how the classes are related to one another, what are the methods and attributes within each of the class, but how how the methods are interacting with another classes with another object is not shown in the structural information structural model. So in order to show how um, how the methods interact one another, what objects, what classes are being called. So that's the need of behavioral models. So it is meant to show the dynamic behavior of a system as it is executing. So this is more like represent what happened between the classes when it is being executed. It show what happened or what is supposed to happen and the system responds to a stimulus. Okay, let's say if somebody clicks some button, a specific button on the screen, what will happen? Okay, so this dynamic behavior model is meant to show uh, what happened if something is being clicked and so on. Okay, you can think of stimuli. When you say stimuli, there are two types. Okay, some data arrive that has to be processed, or event. Okay, event is some things that trigger something to happen. Sometimes it is because the user clicks something on the page or because of certain time. Okay, like for example, for payroll system, every month at certain date, so it will trigger the system to print, for example, the payslip. Right, just now we look at there are two types just now, data and also event. Okay, in terms of data-driven modeling, many business systems are data processing systems that are primarily driven by data. Okay? So, data-driven models show the sequence of action involved in processing input data. Right, they are particularly useful during the analysis of requirement as they can be used to show end-to-end processing. Okay, so this is more like showing the behavior, but the focus is more on the data, right? So in UML diagram, there is a diagram called an activity diagram. Okay, so basically it's showing a sequence of process, all right, whereby um, the square box is actually referring to the data involved. Okay, so blood sugar sensor. So this sensor can catch the sugar level and then pass it to the sensor, right? And then so this is basically showing the processes, right? Um, so this is actually showing how the system behave. Um, in the UML diagram, there's another diagram which can also represent the behavior model. Just now we have seen activity diagram. This is called sequence diagram. So it's basically showing how, for example, in doing order processing, so what are the objects involved? Okay, who are the actors involved? Okay, and then it's showing you the sequence of processes. way to read it, you need to read from up to down. Okay, so the one that is that you see first is done first, all right, and then so it's actually moving, it's actually showing you how the methods actually interact with one another. So what are the objects involved? Okay, so when you see arrow going in, this uh, this is called timeline. Okay, on top of this is the object. So if you see an arrow going here, so it's showing that this is actually a method within this object, and other object actually call this method from budget. Okay, so basically this is showing the behavioral information that it is showing how the methods will be called in executing certain function. So in behavioral, other than showing it through data-driven modeling, you can also show it from the event-driven modeling. So, um, so event-driven modeling shows how a system responds to external and internal events. Okay. For example, if a user clicks something on the screen, it's triggering some behavior. So that's another form of event driven. The same goes like, let's say the system already processing something and there is an output, and that output is being sent um, maybe to another system. That is actually another form of event modeling. Right. To represent event modeling, you can use state machine model. Okay, as as you can see right now, in representing behavioral modeling, there are activity diagram, okay, which is showing the processes sequentially, and then you have a sequence diagram, right? The one that you have seen, there is a box on top, okay, and then there is arrow moving between the objects, okay, and that is and the third one is this one, state machine models. Okay, so it is actually showing the system responses to stimuli, okay, so that uh, are often used, okay, for for state machine modeling models. So normally it is used to represent real-time system. Okay, the notation is slightly different, whereby it has nodes and then it has events, and, and I think there's a diagram like this. Okay, so this is the start and this is the end, and this is actually showing different state, and the arrow is actually showing the event. Okay, so for example, so this is a state diagram for microwave oven. So basically it's showing the behavior of the microwave. Okay, so it can be in the different state. Okay, for example, when it start, it will be in a waiting state. Okay, so the thing underneath this is actually showing a method that can be done during waiting state, and then it can move when it is full power. So it can be in a different state, which is full power, where the power is being set slightly higher. Half power will be the state will if moved to half power, which where the power is being set slightly lower. And then if somebody set a timer, okay, right? If you use the microwave, you can set the timer, right? 1 minute, 2 minute. Then you will set the time, and the state change to set time, right? If the door is open, when you set the time, but the the door of the microwave is not closed, it will not be turned on, right? So if it's closed, the microwave is being unable. It's running right now. Okay, so it's ready, and then it will start. So it will start heating the food, right, and then it operates, and then after that, if after it has operate within the time given, it will stop, and then it will be in the ready mode. The microwave will be in the waiting mode again, ready for the next section. Okay, so state diagram is showing behavioral, but more of showing a real time kind of situation. But microwave is not real time, but it can also show the changes of states, what happened, uh, to move from one state to another state, what triggered it, okay, what methods involved, like that. Okay, state machine also can be represented in a different level of detailness. Okay, just now, when you have seen a state which is called operation, right? When it is actually running, uh, so you can make it capturing it in a greater detail. What happened actually during the operation state? Okay, so they will be checking state. Okay, and then you check the status first, and then if it's okay, then you will start cooking, start heating it. Okay, so and then after the time out, let's say I set it to 1 minute. After 1 minute, it will be done, and then normally it produce you a sound. Okay, let's say during the checking time, there's some fault. Okay, it will be showing something on the screen, or uh, sometimes a simpler microwave uh, does not do anything, right? It simply freeze. Okay, so what you have seen this is actually is also a state chart, but is emphasizing uh, or highlighting only one state, whereby it is showing inside that one state there is actually more detailed processes happening there. You can read that yourself. All right. So what we have seen so far is actually we have seen the usage of models whenever you are doing design. So because at this point of time when you do design, you are trying to make the analysis that you obtain in the previous phase, or requirement engineering that you have done in the previous phase, you want to make it slightly more detailed so that you can actually give it later whatever that you have done during the design process to the programmer, so you can represent it in the form of model. So this model is an abstract view of the system that ignores system details. Okay. So as you can see just now, there are many models. The behavior model is the more detailed one. Okay, so it's trying to catch some system details inside it. Uh, Complementary system models can be developed to show system context. Right. So this is the most the general overview. So normally you use this information with the user, and then later you want to capture the interaction structure. You want to know what classes involved, how they are related, and then you want to capture the behavior. So behavior basically you want to know how the system actually um, when it is running, what processes is actually involved. Okay, as you can see just now, the first one, which is context model, is basically trying to show how the system, uh, the position of the system in its environment. Okay, what are other system involved? What are other processes that need might be involved? And this is actually used to scope down the providing scope information for the system. And then you have use case diagram and sequence diagram. Okay, can be used for interaction. I think just now when I was explaining, sequence diagram can also capture the behavior. Okay, so this sequence diagram can be used to cap not only for interaction but also for behavior. Right, use case diagram. If you still remember, you want to capture the interaction between the system and the actor. The actor here refers to the users and also other system that might be interacting with uh, the system that is going to be developed. Whereby for the sequence diagram, it add more information, slightly in the greater details to show what objects are involved and how these objects interact with one another. And then we take a look at structural model. So it's basically we want to know the structure, and then we want to know how the classes are being organized, and the architecture. Architecture is basically the overview of um, how the classes will be organized. Okay, and class diagram is being used to represent structure information, where it is basically showing the static structure. We only know what classes evolve, how do they react, it is not known. So that's why we have another model which is called behavioral models, which is used to describe how the objects interact with one another as though it is being executed. Okay, so it is modeling it from the perspective of data driven, and also for event driven. So there are two ways on how to do this. Right, so we have activity diagram, which is a way of representing the behavior from the data perspective. Right, so it's basically showing step by step activity, what are the data involved. Then we have also representation of behavioral model, but from the event perspective, where it can be done through state diagram, where it capture the responses of internal and also external.